Hello everyone, here is a question based on mole concept and limiting reagent. Consider the reaction given below. If 174 gram of butane reacts with 320 gram of O2, find the volume of water formed in milliliter. Density of water is given as 1 gram per milliliter. We know that density is equal to mass by volume. We need to find the volume. Density is given, so that means we need to figure out the mass. Let us first check whether the reaction is self balanced or not. On the reactant side we see 4 carbons, on the product side too we see 4 carbons, on the reactant side we see 10 hydrogens, on the product side too we see 10 hydrogens because 5 times 2 10, and then on the reactant side we see 13 oxygen atoms because 13 by 2 times 2, so it would be 13. On the product side too we see 8 plus 5 13. So therefore the reaction is already self balanced. Now let us write the stoichiometric moles. How do we write stoichiometric moles? Number of moles of butane divided by 1. Whatever is the stoichiometric coefficient, we just bring it down, and then number of moles of O2 divided by 13 by 2, and then number of moles of CO2 divided by 4, and number of moles of water divided by 5. Now depending upon which one is the limiting reagent, whether butane is the limiting reagent or O2 is the limiting reagent, that we need to figure out, and then depending upon that we have to compare the stoichiometric moles with the stoichiometric moles of water so that we can find out the answer. Now let us find the number of moles of butane and number of moles of O2. Number of moles of butane is equal to mass divided by molar mass, so 174 gram, that is the given value here, and the molar mass of butane is 4 times 12, that is 48, and 10 times 1, so 58 gram per mole. So therefore this is 58 gram per mole. So this means this will be 3 moles. Number of moles of butane is 3 moles. How about number of moles of O2? Number of moles of O2 will be 320 gram, that's the given weight, divided by molar mass of O2 is 32 gram per mole because 2 oxygen atoms, so 16 times 2, so 32. Therefore this will be 10. Now which one will be the limiting reagent? Limiting reagent is number of moles of reactant divided by stoichiometric coefficient of reactant, and whichever is smallest out of that is the limiting reagent. So for butane, what is the number of moles we found? It was 3 moles, stoichiometric coefficient is 1, so therefore 3 by 1 is 3. How about O2? For O2 we found that 10 moles, stoichiometric coefficient is 13 by 2, so therefore when the 2 goes up it would be 20 by 13. So obviously 3 is greater than 20 by 13 because this will be somewhere around 1.5 something. So therefore which one will be the limiting reagent? The O2 is the limiting reagent here. So therefore what we need to compare? We need to compare the stoichiometric moles of O2 with the stoichiometric moles of water. So therefore 2 times number of moles of O2 divided by 13, I just brought the 2 up, equal to number of moles of H2O divided by 5. So therefore number of moles of H2O is equal to 10 times number of moles of O2 divided by 13. Number of moles of O2 we found was 10 moles. So therefore 10 times 10, therefore 100 by 13. Now we need to figure out 100 by 13. So let's do that. So 7 times will be 91, 7 times 13, is 91. Remaining 9 we can't divide, so put a 0. And then 6 times 13 is 78. Remaining 12 we can't divide, so put a 0 once again. And then if we do 9 times 13, then it would be 117. So remaining 3. So we will just keep it to 2 digits, 7.69. So therefore, number of moles of H2O is equal to 7.69 moles. So therefore, mass of H2O is equal to, molar mass of H2O is 18 gram per mole. So 18 gram per mole times number of moles of H2O, that is 7.69. Therefore, mass of H2O 769 times 18. 9 times 8 is 72. So 2 remaining 7. 8 times 6, that would be 48. 48 plus 7, so 55. 5 remaining 5. And then 8 times 7, that would be 56 plus 5, so 61. And then 9, 6, 7. Therefore 2, 9 plus 5, 14, 4 remaining 1. So 7 plus 1 plus 1, so 8. And then 7 plus 6, 13. Therefore 138.42 gram. That's the mass of H2O. Now volume is equal to mass divided by density. So therefore 138.42 gram divided by density is given as 1 gram per milliliter. So therefore gram we can cancel. So it would be 138.42 milliliter volume is. So if we want the nearest number, then volume is equal to approximately 138 milliliter. That's the correct answer.